In the last video, we did a moving average. We discussed two ways to do it, using formulas and also using the data analysis tool pack for moving average. We set up this table to have 1 month represented as a number 1 through 12 for each year, and the range goes from 2013 to 2018. In the period column, we started with 1 and just copied down to 72 periods. If you recall, the first period, January 2023, was deleted because we didn't have any data for that range. Then we found the average close price for each month and year using a formula like this, using the averageifs formula specifically. So now we're going to do a weighted moving average, and the first thing that I'm going to do is copy this table that we set up already so that we don't have to set it up again. Now I used Control-C to copy, and I'm going to go to a new sheet tab, and in cell A5 I am going to do a value paste. So to do a value paste, instead of a normal Control-V that you would use to paste, or the normal paste, you would hover over the paste in the Home tab, in the Home ribbon, and then where the clipboard says 1, 2, 3, and then it says values in the tooltip, you would select there. So what this did is it only pasted the value that it evaluated to. It didn't paste the formulas. I'm going to do some quick formatting. And the next thing that I'm going to do is assign some weights. So in the simple moving average, the previous periods that we use all count equally. But in this case, they will not. So if the time period is now, t is now, t minus 1 is last period, t minus 2 is 2 periods ago, t minus 3 is 3 periods ago, and t minus 4 is 4 periods ago. We're using monthly periods in this example, but you could also use a forecast on weekly periods, daily periods, even hourly periods. For now, I'm going to set them each to have the same weight. I'm giving them each a weight of 1. Now, let's add a cell for weighted moving average. You could also just call this WMA for short. Now, if we want to do, say, 4 periods, we need to basically multiply these 4 periods by their weights in order to weight them differently. And so I currently have them weighted the same, but in practice we usually give more weight to the more recent time period. So suppose I give the most recent time period a weight of 2 instead of just 1. Since I need to multiply these 4 values by these 4 values, then I'm going to start working here with building the weighted moving average. We can use sum product, which is an Excel formula that returns the corresponding ranges or array. So basically it's going to return the sum of when you multiply those numbers together. Array 1 is going to be these first 4 periods that we have for the average close price of the American Airlines stock data. I'll use a comma as a separator. Please keep in mind that not all versions of Excel use a comma. Some versions use a semicolon, for example. And when you've moved to the next argument will be bolded. And so this now wants the second array. In this case, it's going to be the weights. We need to lock this down so that way when we fill down in the cells, it will not move the weights. So I can use F4, and on some keyboards, it's the Fn plus the F4 button. And if you still have trouble, you could just enter in the dollar signs as well. I will close my parentheses, but I'm not quite finished because we also need to divide this by the sum of the weights. So I added a division bar to my formula, and then we can use the sum function, and we're also going to take the same range here, H1 through H4 in this example, and I'm going to press the F4 key so that I have an absolute cell reference, so when I fill down, this does not fill down with it. It's going to stay right there. And so when I press enter, I get this weighted moving average. And when I double click on the formula, I can now view the things that went into the formula. So it's this value times this value, plus this value times this value, plus this value times this value, plus this value times this value, and taking all of that and dividing it by the sum of this range here. We can now use the fill handle to fill the cells down. You can either drag them down manually, or you can hover on the fill handle and double click, and it will fill down all the way. So we notice that our formula seems to work great here. But here, we notice it starts to get smaller. There's now a 0 averaged into our formula, until eventually all zeros are averaged into our formula. This occurs because March 2018 through December 2018 are not in the data set. They are the future of this data set. So we do have a forecast for one period since we were able to take the weighted moving average of the 4 previous periods. But we need to do something here. So first, to indicate that this is the future, I'm going to give it a color. And then I'm going to set this period equal to the forecast. So I'm setting the actual as equal to the forecast to extend the forecast out. I can fill that down. And then let's take a look at what it looks like on a graph. I'll select the entire area, insert, a line chart, and let's just bring it to the top of the page. I'll make it a little larger. So we could play around with these weights and see how it affects the forecast. Suppose I give the most recent time period a lot more weight. Suppose I gave 4 periods ago 0 weight. And you can see that the weighted moving average, which is the forecast in this case, changes slightly compared to the actual, which is, in this case, the blue series. Now, Excel has a cool tool where we might be able to try to optimize this. And to optimize this, we'll need to create some kind of error metric. We're going to use absolute error. Since we're using the absolute value, we're going to need to use an absolute function. The ABS function in Excel is for the absolute value, and the error is simply the average minus the forecast. So we can put that inside of the function. So, not the average, the actual minus the forecast. The actual average close price is here, minus the forecast is here. So we have an error that our forecast is off by about 43 cents. When we fill this down, we only want to include periods that have actual data. We don't want to have an error based on the future of the data set. Next, we can set up to find the mean absolute deviation, which is the average of the absolute error. So we can use the average function, select the first value in the absolute error column, and use Control-Shift down to select the entire data range. This is our value. Next, we're going to try to use the Excel Solver tool, and we're going to see if Excel can come up with a better solution. A better solution for our weights, that is. So if you go to the Data tab, you should have Solver, and if you don't have Solver, you would go to File, Options, Add-ins, Excel Add-ins, Go, and make sure the Solver add-in is checked. Click OK, and you should see it pop up just there. Solver allows us to use some parameters to set some different values. So we want to set the objective, and the objective that we're interested in here is J2. It's our mean absolute deviation value. And we want to minimize it because we want it to be as small as possible. We're basically saying on average our forecast is off by this amount, and we would like to have our forecast off by the smallest amount possible. And what we're going to change will be the weights. And we want to make the unconstrained variables non-negative. This ensures that we don't get any negative values in our weights, so ensure that this box is checked. And we don't have any additional constraints in this case, so we can try to solve. Looks like I got an error this time. I'm going to try to reset my weights and try it again. This time Solver found the solution for me, and I'll click OK. And my solution is putting lots and lots of weight on the most recent time period, and it's not placing any weight on the time periods before that. We do have to be careful when we use these solutions because sometimes they might overfit models or things like that. It looks like we have pretty much an exactly fitted model that's about one step ahead. It also flattens out toward the end, and that's also typical for this type of forecast. We would typically use a weighted moving average forecast when our data does not have a trend, and this data does seem to have a trend. I'm going to try the solver one more time, but I'm going to add some constraints so that way we have some limits on how high each weight can be. You can see that in this case I want them to be less than or equal to 10. So I want to minimize where the values of these weights can be between 0 and 10. Again, it looks like they really maximize that t minus 1 time period, so it's giving all of the possible weight there. But this time the solver found a solution without giving me an error.